Today, I will be talking about asteroid mining feasibility. I will start by giving a brief background on asteroids. Asteroids are rocky, airless remnants from the creation of our solar system many years ago. Most of the asteroids in our solar system are found in the asteroid belt, which exists between Mars and Jupiter. There are many things we do not quite fully understand yet about asteroids, as what we know comes from observing them from afar or from analyzing chunks that have fallen to Earth. There are three different types of asteroids. C-type, also known as carbonaceous chondrite asteroids, are made of silicates and clays. They are dark in color and are the most common asteroid. S-type, also known as stony asteroids, contain silicates and some nickel and iron. M-type, or metallic asteroids, are mostly made of nickel and iron. The continued depletion of our natural resources and the fact that the demand for natural resources, especially metals involved in electronics, continues to increase has caused people to look for other ways to get these said resources. One of these potential options is asteroid mining. Asteroid mining would consist of building technology and sending it into space so that we can mine the minerals and resources that are in an asteroid. For example, asteroids have resources such as plutonium, iron, and water. Water as a resource may surprise many, but water is important in space because it can be used to make oxygen and rocket fuel. In fact, C-type asteroids are seen as the most valuable asteroids because they contain water. At the moment, there are many obstacles to asteroid mining. However, the future of this industry is looking very promising. The obstacles of asteroid mining. The first obstacle to asteroid mining is the legality of it. Despite laws existing that have to do with space, there are a lot of unclear parts when it comes to mining in space. For example, the 1967 Outer Space Treaty is unclear on who would have ownership of any mined resources, as it prohibits the appropriation of celestial bodies by individual nations, which means that there is no clear security of tenure, which is secure and stable rights throughout the entire mining cycle. When it comes to asteroid mining, though, it is necessary that there is international agreement and cooperation in outer space, as the Outer Space Treaty requires that space is used peacefully. Another obstacle to asteroid mining is simply the fact that the technology to do so does not quite exist yet. We cannot use traditional mining technologies in space due to the microgravity environments on the asteroids. If we tried to dig and drill, there is a chance that the asteroid would just crumble. This would fling rocks into space and would mean that we would not be able to efficiently extract all the resources we possibly could from the asteroids. Although there are prototypes that are being tested, currently there is no technology that has been proven to work in space. The picture on this slide is a model of one of the said prototypes. It is called the Mini B. Another problem in terms of technology is the power source. A lot of power will be required to mine, especially since most likely robots, not humans, will be mining the asteroids. For reference, the International Space Station has 35,000 square feet of solar arrays and generates up to 120 kilowatts of electricity. The mining equipment on estimate would need a similar size power plant, and that is just for one tool. The power source for these machines would have to be solar. However, our solar panels currently are not good enough at converting solar energy into electricity for them to be usable for asteroid mining. Another big obstacle to asteroid mining is the cost of it. The research and development of technology requires a large sum of money from potential investors, And since the industry is a big gamble, there's a chance that these investors never get anything in return. There's a joke in the industry that the best way to become a millionaire in space is to start as a billionaire. Furthermore, the only way this enterprise will be able to start is if it makes a profit. However, this would require going to space, mining the resources, and bringing them back to Earth. As of right now, this would not work financially, especially when we have the exact same resources on Earth. Despite all the obstacles that currently prevent asteroid mining from occurring, the future of the industry is looking bright. Over the past decade, there has been an increase in interest in space. Nothing shows this better than the way that within the past year, there have been multiple private companies that have gone up into space, and the fact that there are currently at least 4 companies trying to build cheaper space stations. With the increase in interest to go to space, this means that there have been improvements in technology as there is now demand for the products. These improvements are bringing down the cost of space. People have also been wanting to find a more sustainable way to get metals and resources, as mining on Earth is very disruptive to the environment. Asteroid mining is looking like it could be a potential solution. In terms of laws, many countries have started making agreements and laws to clarify what is allowed in space. For example, in 2020, the US negotiated the Artemis Accords, which are meant to guide lunar exploration. In conclusion, there is still a lot of work to be done before asteroid mining is a reality. The technology for it needs to be working, the exact rules and regulations need to be made clear, and the cost of the whole adventure needs to go down. The future is looking very bright for the industry though, as progress is being made on many of the current obstacles. This leaves the question of when will we start mining asteroids? Well, as of right now, the first mining machinery is expected to launch in 10 years' time. However, there's still a whole lot of uncertainty around this, so who knows when asteroid mining will be a reality.